Hello, class. This is Miss Shawande. I hope everybody's doing well and they had a great 3-day weekend. We're going to continue off of what we learned on Thursday, and that is the composition of the atmosphere and the air pressure. Let's begin. For today's warm up, you should have already been working on it, so we're just basically going over it. So, today's warm up, the questions were: why are there no clouds in the stratosphere, and what atmospheric layer does the weather occur? This should go into your warm-up section. If you filled your papers in 4, which you should have already done, you can do 4 in the front, and your 4 warm-ups in the front, and your 4 exit tickets in the back. So, yes, you do have to write down the questions and answer the questions in complete sentences. So, before we answer the questions, you also need to copy in your agenda 7.E.1.1. Copying your agenda, complete 7.E.1.1 Part 2 flashcards due on Tuesday and complete weekly assignment. Alright? So, why are there no clouds in the stratosphere? The reason why there's no clouds in the stratosphere is because it's very dry. And we know for clouds to form that there has to be moisture. Without moisture, the clouds cannot form. So that is why there's no clouds in the stratosphere. The next question is, what atmospheric layer does weather occur? The atmospheric layer that weather occurs in is the troposphere, which is the layer right underneath the stratosphere. This is the layer that which weather occurs. Alright, so what I need you all to do now is pause the video and take out the article. Before you pause the video, take out the article that I gave you on Thursday. We won't be doing any group reading. We'll read it individually, and you'll answer the 3 questions in your assignment section of your binders. Go ahead and finish doing that, and after you do so, you can continue to play your video. That will be checked for a grade, so you have the heads up. On Friday, I will be collecting all binders and grading each and every assignment we've done for the week. Welcome back. So, what is the composition of the atmosphere? How does this affect the weather? So, what I need you all to do now is go ahead and write this on top of your notes or in the corner of your notes, if your photo book covered the whole top. Go ahead and write this in the corner so that you know this is the topic that you will be able, or the question you will be able to answer by the end of this section. Alright, what is the composition of atmosphere? How does this affect the weather? Before we can start, the first thing we need to know is, what is weather? I know that sounds like an easy question, but truly, what is weather? Weather is the condition of Earth's atmosphere at a particular time and place. So it's just the condition of the atmosphere at a particular time and place. Alright? Now, what I want you to remember, because if you just look at your notes that we took on Thursday, is what is the atmosphere? It's the mixture of gas that surrounds the planet. So it's the mixture of gas that surrounds the planet, and we know that we have 5 different layers. We have the exosphere, which is the very outer, the thermosphere, the mesosphere, the stratosphere, and the troposphere. Alright, and the troposphere is the very inner and also the layer that we're actually currently in. Alright, so if you couldn't remember, all you have to do is look back at your notes that we took on Thursday, and you would see the different layers and what consists of in each layer. Alright, now that we talked about the different layers and what consists of each layers, we're going to go to air pressure. And I know you're all like, what is air pressure? Air pressure is the force, and remember you guys learned force inside 7.P.2 and point 1, that force is basically it's the force pressing on us by the masses of the air molecules. All right, so we have all these air molecules left, right, above us, below us, pressing down on us or pressing on us. And the only reason why we're not being crushed is basically because we have our own air molecules within us pressing back. So that's the balance of reason why we're not being crushed. Now, the funny thing about these air molecules, they're more denser at the bottom layers of the atmosphere and less denser at the top layers of the atmosphere. So if we go up the atmosphere layers. So if we increase in altitude, we'll notice that the density of the air molecules, and basically that means the way it's compressed, the way that they're all compact together, is more at the troposphere than it is at the exosphere. All right, it starts to decrease as you go up. Also, because the density is decreasing, the air pressure that we're also having is decreasing. So all that air molecules that are being pressed down on us as we go up the altitude or up the layers is decreasing. Now, what I need you guys to do is go ahead and turn to the notes that we took on Thursday. Those two arrows that you see on the side, and let me go ahead and show you exactly what I'm talking about. These arrows right here and the words that are near it. I want you to go ahead and draw that right beside your photable of Thursday. The photo that we created on Thursday, go ahead and draw these arrows right beside there. All right? And then right as altitude, so as you see the arrows going up, that's our altitude increasing. The air pressure and density is decreasing. That is very, very important for you to know. All right? Now, as we talk about air pressure in the troposphere, which is on Earth, it varies based on several factors. The first one is temperature, and the other one is humidity. All right, so when air pressure is high and it moves to an area of low air pressure, wind occurs. And I know you're looking at like, I don't understand. So let's think about it like this. If I had a balloon right now and I filled it up with air, that is considered high air pressure because the balloon has compressed, we've compressed all this air into this balloon. And if I had a piece of paper or pieces of papers on my table and I released the balloon so that all the air in the balloon would blow the paper away, the air in the balloon went from high pressure to low pressure because there was not that much air pressure near those papers. So all this compact air now blew all these papers away, causing wind. I know that that might be a little confusing, but as we move on and you see in 7.E, that will be explained better, especially when we talked about winds and weather in detail. The other thing I want you to know about air pressure is that when you're considering it with weather, high air pressures equals to clear and dry conditions, and low air pressures equals to tornadoes, storms, and hurricanes. Now, what I wanted you guys to do is make sure that you guys are jotting down these notes. So this is actually going on the page that you did notes yesterday on Thursday on. So make sure you jot down these notes. And I know some of you may have very small spaces, okay? You're just jotting down the notes so that you guys can refer to it at a later point in time. All right? So now that we talked about air pressures and air molecules, we're going to talk about the gases, the air that is in the atmosphere. So what is in our air? What are these gases that makes up our air? All right, and you're going to basically put the information inside your foldable, just like we did on Thursday. Before we do that, I thought it was really interesting to kind of show you guys what the different layers look like. So this picture is basically upside down, just letting you know now. That is why the troposphere is on top, but it's upside down, so we can see the troposphere where we are, where clouds are. Then we see the stratosphere, not that many clouds. The mesosphere, where we can see our meteors. Our thermosphere, where it's like awkward temperatures. And then our exosphere, where we usually see our stars. Alright? Now, the composition of the atmosphere, those special gases that we were talking about earlier. Here are the list of the different gases. We have nitrogen at 78%, oxygen at 21%, argon at 0.93%, carbon dioxide at 0.04%, and trace gases and water vapors. I know this is a little different than what the article stated. You'll see it differently on different papers, but this is the main one that I want you to know. So 78% for nitrogen, 21% for oxygen, 0.93% for argon, and 0.04% for carbon dioxide. And the reason why we don't have percentage for trace gases and water vapors is because they're so small. But I promise you all that they're there. Now, go ahead and write your notes for nitrogen. Nitrogen is the most abundant gas in the atmosphere. It's essential to living things needed to grow and repair cells. And bacteria convert the nitrogen from the air, and then plants use it to create protein that people and animals need. So this nitrogen that's from the air, we don't breathe it in because that would be toxic for us. However, it's a cycle that the nitrogen goes through, and it's very amazing. And it's called the nitrogen cycle. And this nitrogen cycle is used through plants, and we use it, but it's these bacteria that convert it for us to use. And you'll learn this more in detail in the 8th grade. But this is just an introduction of, hey, there's a gas called nitrogen in the air that we use to repair our cells and to grow our cells, and we use it to get our protein out of also. So this is really amazing. And it's the largest amount. Again, it's 78% of the air and of the gases in the atmosphere. The next one is oxygen. Oxygen is the second most abundant gas in the air. It's used by plants and animals, so we know that we breathe in oxygen. We use it very well, and plants breathe out oxygen. That's how we get it. All right. And also, a really cool fact is ozone, which is O3, is formed when lightning interacts with the oxygen. So our ozone is basically formed when we see lightning interacting with the oxygen. That is our ozone. I think that's incredible. So, guys, little things like that is really interesting to know. All right. The next thing is argon. Argon is pure raw material used by industries to produce purified argon products. So, I know you guys are like, so which ones are purified argon products? So, when you think about a distilled liquid, that's argon products. Or when we think about neon lights, it's mixed with another element to create these neon lights. Those are argon products. So this gas that's not very much, we actually use it very, very often, and it's kind of awesome to see what it produces. The next thing is carbon dioxide. Carbon dioxide is essential to life. It's also essential to plants because it's used to make food. It's essential to us because we breathe it out. So as we breathe in oxygen, we breathe out carbon dioxide through respiration. And plants use it for food through photosynthesis. So those are two awesome processes that we get carbon dioxide out of. Now, the next thing is water vapor. Water vapor is the amount in the air. Well, now, water vapor, the amount of it varies from place to place. basically, depending on where you are, determines how much water vapor we have. So that's really why we didn't give a percentage of it, because it varies. And it plays an important role in the Earth's weather, cloud, and precipitation. So this water vapor that we have can determine helps us with our different types of weather. It also helps us with the formation of clouds and precipitation. Precipitation is not only rain; it could be snow, sleet, hail, all of that. It helps with this. So water is very important. And the last but not least are the trace gases. I know everybody's like, what is trace gases? These are just different types of gases that they see that we have hints of it inside our atmosphere. And they're so small, we just gather them all together because they don't even take up a big portion of our atmospheric composition, but they're only in small amounts that are present. So these are just in small amounts that are present, but they are present. So we give them some form of consideration. All right. Now, I do want you to write this down. These gases that are put in our atmosphere are by the following processes. So we have photosynthesis, and we know that at least two gases that can be put in from there: oxygen and carbon dioxide. Respiration, the same thing. Evaporation, we have water, but then also, if you think about seawater where it evaporates, we can get argon, we can get trace gases from that. So, evaporation is also very important. And evaporation is basically when water turns from a liquid to a solid, or not only water, but any liquid turns from a liquid form to a solid form, changing its state of matter. And then we have condensation. Condensation is basically when a gas cools itself off. Let's use for example water. When water is in its gas form, or water vapors, and it gets cooled off, it starts to come together and condense, forming back to a liquid. So condensation is very important. And then weathering of rocks. I know people are like, weathering of rocks. What does that mean? Weathering of rocks is just a breakdown of the rocks. You have two types of weathering. You have chemical weathering and you have mechanical weathering. These two processes help with the different gases in our atmosphere, so it puts it in the atmosphere for us to use. And the last process is the decay of organic material. Organic basically means living. So our organic materials that are being decayed, this also helps with putting the gases in the atmosphere. And one major gas that I know that occurs through decay of organic material is nitrogen. So that is really amazing to know, all right? Now, you guys have a little bit of a classwork assignment to do for me. I know this video is longer than I would have wanted it to be, but we're almost done. Alright, so you're going to use the resources that you have to create a comic strip explaining the arrangement of the air molecules and how it plays a role with the air pressure in the atmosphere. So you're going to show me a comic strip, and it's going to explain the arrangement of the air molecules and how it plays a role in the air's atmosphere. Plays a role with air pressure in the air's atmosphere. You must make sure it's colorful, with mentioning the different way. Make sure it's colorful and mention all the ways that it would affect the weather. So you're going to not only show me how the air molecules occur and how it plays a role with the air pressure, you're going to show me how it affects the weather also. Alright? And last but not least, you are on the back of your warm-up sheet behind the square. So you've already folded your warm-up sheet. You're going to create your exit ticket. And on your exit ticket, you're going to explain how wind is created by air pressure present. And then you're also going to explain the arrangement of the air molecules as we move through the atmosphere. So as we ascend or as we increase in altitude, explain to me how the air molecules are. Alright? If you have any question, quietly raise your hand. Everybody should be staying on task, and I'll talk to you guys later.